the chapter we are going to discuss now is purification and characterization of organic compounds. Purification and characterization of organic compounds. This chapter will be discussing under three headings. Number one is qualitative analysis of organic compounds. This basically deals with elemental analysis, identifying the various elements present in the organic compound. Two elements are quite obvious, carbon and hydrogen. Apart from that, we'll be trying to learn about other elements which are present in the organic compound and how to identify those elements. Under quantitative analysis, we'll be talking about how to determine the percentage composition of each element present in the organic compound. You can find out percentage composition of elements, and from that you can arrive at empirical formula of organic compound. The last thing we'll be learning is regarding various purification techniques which are employed for purification of organic compounds. So these are the subheadings we'll be discussing under this chapter, purification and characterization of organic compounds. Let us start with qualitative analysis of organic compounds. As I told you just now, in this basically we'll be learning about elemental analysis. Number one, we'll find out about detection of carbon and hydrogen in organic compounds. Let's see how carbon and hydrogen are detected in organic compounds. Take organic compound and heat it in presence of cupric oxide. Cupric oxide is not a stable oxide. It has an ability to decompose and release oxygen. Copper oxide itself transforms into metallic copper. The oxygen produced by cupric oxide here will oxidize the carbon and hydrogen present in the organic compound. Carbon gets transformed into carbon dioxide and hydrogen gets oxidized to water. The oxygen being supplied by cupric oxide. Now it's a matter of detecting these two substances which are formed in the reaction. You know very well, CO2 is detected by using lime water. CO2, carbon dioxide, turns lime water milky. The milkiness is due to formation of CaCO3. This is responsible for milkiness. This is your lime water. So this reaction indicates that carbon dioxide is formed in the reaction, and this in turn tells you that the original organic compound contained carbon. Apart from this, water, for example, the formation of water can be tested by using anhydrous copper sulfate. Anhydrous copper sulfate is colorless. Anhydrous copper sulfate is white or colorless. Now, when it comes in contact with water, you get CuSO4.5H2O, which is blue. So, if the white copper sulfate turns blue, that indicates water formed in the reaction. So, this is how carbon dioxide and water are tested. There is another substance which can be used, cobalt chloride. Anhydrous cobalt chloride is blue, and when it takes up water, it becomes pink. COCl2 becomes COCl2.2H2O. This is pink, this is blue. So this is another way you can test water. Here I would like to add one point, that even sulfur dioxide gives lime water test. So to make sure that the gas formed is carbon dioxide, you should pass it through acidified potassium dichromate. Sulfur dioxide turns it from orange to green, whereas carbon dioxide does not turn the color of acidified potassium dichromate. That is about detection of carbon and hydrogen. Organic compound is heated with copper oxide. All the carbon and hydrogen present in the organic compound are oxidized to carbon dioxide and water respectively, and these are tested in this way. Carbon dioxide by lime water, and formation of water can be tested by using either anhydrous cobalt chloride or anhydrous copper sulfate. Let us now see how other elements are detected. Detection of other elements. Here, let's learn about a named test called as Lessines test. Lessines test. Here, organic compound is subjected to fusion in presence of sodium metal. The idea is to transform all the elements in the organic compound into ionic compounds of sodium, and then they can be tested easily. This is then mixed with distilled water. All the ionic substances will dissolve in this, and then filtration is done, and the filtrate is called as sodium extract. Now, this sodium extract is used to test for various elements present in the organic compound. Let us look at them one by one. Under this, number 1, detection of nitrogen. Let us see how the element nitrogen is detected in the organic compound. We have already prepared sodium extract. I will tell you, organic compound is subjected to fusion with sodium metal, and then it is dissolved in distilled water and filtered. The filtrate is called as sodium extract. The sodium extract can be used for detection of other elements present in the organic compound. Other elements means other than carbon and hydrogen. Now, if any nitrogen is present in the organic compound, this reaction which is supposed to take place is this: Na plus carbon of the organic compound will react with nitrogen, and you get an ionic compound NaCN. So, it is just a matter of testing presence of Cn minus in the extract. What you need to do is add ferrous sulfate. Add ferrous sulfate solution, you get Na4 FeCN6. You can call it as sodium hexacyanoferrate. Now, of course, you have some extra ferrous ions present in the solution. Now, you need to add concentrated sulfuric acid. So, any ferrous will get oxidized to ferric by concentrated sulfuric acid. Now, this ferric will combine with this to give a Prussian blue colored substance. The chemical name is ferric ferrocyanide. Look at this: FeCN6 4 minus plus Fe3 plus, and get Fe4 FeCN6 taken thrice. This substance is colored, it is Prussian blue. The complex is ferric ferrocyanide, Prussian blue coloration is obtained. So, formation of Prussian blue coloration is an indication that there is a nitrogen in organic compound. This happens during fusion with sodium, and then we put in the extract, you have sodium cyanide, then we put ferrous sulfate and you get sodium ferrocyanide. Now, you add little sulfuric acid which will oxidize some of the ferrous ions into ferric ions, and those ferric ions combine with ferrocyanide to give a Prussian blue colored complex, and this appearance of Prussian blue coloration is an indication that nitrogen is present in the organic compound. Let us now learn detection of halogens. Detection of halogen in the organic compound. But remember, this is it comes under Lassane's test only, but it is applicable for chloride, bromide and iodide. Why not fluoride? You will realize when you learn this method. See, what you need to do is the extract should be mixed with dilute nitric acid. Because the sodium extract is alkaline, you need to transform it into acidic solution, because you are going to add AgNO3. If you do not add this, then there is a possibility that you will get silver hydroxide, which will decompose to give black silver oxide. To avoid this side reaction, you need to make the solution acidic. Now, if any halide is present in the extract, you know, this is the reaction which is supposed to take place. Na plus X gives NaX. This is the halide which is halogen which is present in the organic compound. This happens during fusion. So, this will dissolve in the extract, and now you are trying to find out with the help of AgNO3, you are supposed to get a precipitate of AgX. So, formation of AgX is an indication that the original organic compound contained halide. Now, this precipitate, if it is white, then it indicates that X is chlorine. If it is pale yellow, then it is an indication that X is bromine. If it is yellow, then this is an indication that X is iodine. Another important thing you already know, that if it is AgCl, it will be soluble in a solution of ammonia, whereas if it is AgBr, it will be sparingly soluble, and if it is AgI, it is insoluble in ammonia solution. So, if a white precipitate is obtained which is soluble in ammonia solution, then it is an indication that halogen, that is chlorine, is present in the organic compound. If you get a pale yellow precipitate which is sparingly soluble in ammonia, it is an indication for the presence of bromine, and if the precipitate is insoluble in ammonia, it is an indication that iodine is present in the organic compound. One important piece of information you should know, I have already told you the purpose of adding dilute nitric acid is to make the solution, to transform the alkaline extract into acidic solution, so that AgNO3 which is going to be added should not transform into silver hydroxide, which may become a black precipitate of silver oxide. Another important point which is supposed to be kept in mind is, if presence of nitrogen has already been established and now you are detecting halogen, then it becomes compulsory for you to boil the extract with concentrated HNO3, so that cyanide, which is a pseudo halide, is oxidized and removed as carbon dioxide. Otherwise, it will interfere with this reaction. Even cyanide also, this is possible. Ag plus, which comes from AgNO3, which will then combine with cyanide to give a white precipitate of AgCN. So, if you do not expel out cyanide, then there is a interference of cyanide. You may get misleaded. So, it is important that if the compound contains nitrogen, then testing of halogen should be done after boiling the extract with concentrated HNO3. Concentrated HNO3 will oxidize cyanide and expels out carbon as carbon dioxide. Let us now discuss about detection of sulfur in the organic compound. Sulfur. See, the reaction which is supposed to take place during fusion is, if sulfur is present in the organic compound, then it is supposed to transform into Na2S. Now, it is just a matter of testing presence of sulfide in the extract. You can add, see, sulfide is present in the extract, right? Then you can add this substance, lead acetate. Lead acetate is a soluble salt of lead. Now, you get PbS, which appears as a black precipitate. So, formation of black precipitate with lead acetate is an indication for the presence of sulfide in the extract, which in turn indicates the presence of sulfur in the organic compound. Number 2, sulfide plus this substance. This is Na2FeCN5NO. You get this FeCN5NOS, which has a 4 minus charge. Right. This is a red colored substance, whereas this is purple colored complex. This substance is called as sodium nitroprusside. So, if sodium nitroprusside is added to sodium extract, then you get a purple colored complex. So, formation of purple colored complex is an indication for the presence of sulfide in the extract or sulfur in the organic compound. Here I would like to add few things. In this complex, NO is a 3 electron donor. Another point I should add here is Fe is in the +2 state. Here also Fe is in the +2 state. So, there is no change in the oxidation state of Fe in this reaction. And also remember that NO is a 3 electron donor. Here it is a positively charged species. If nitrogen and sulfur both are present in the same organic compound, then what happens is, in the preparation of sodium extract, this type of reaction takes place. Na, S, C and N. These three elements combine with sodium and you get a substance like this, sodium thiocyanate. This is sodium thiocyanate. This is formed only when you have both sulfur and nitrogen in the same organic compound. So, this can be detected using this. You add ferric salt to sodium extract. This is sodium extract which contains thiocyanate, ferric salt. This is ferric salt. Then you get a complex species of this type. This has a blood red color. So, this appearance of blood red color indicates presence of thiocyanate in the extract, which in turn indicates that both sulfur and nitrogen are present in the organic compound. But then remember, this happens if you take limited amount of sodium during fusion. But if you take excess of sodium, you don't get thiocyanate. If you take excess of sodium during fusion, you don't get thiocyanate, you separately get Na2S and NaCN with excess of sodium. Let us try to look at this compound and let us try to answer this question. I have benzene. This will not give test for, obviously there is no nitrogen, there is no sulfur, there is no heteroatom in this compound. So, you do not get test for any heteroatom. But suppose you have this, then the Lessein's extract of this substance will give white precipitate with AgNO3, that is because of formation of AgCl. And look at this substance. This is called benzene sulfonic acid. Here you can expect it to give test for sulfur. It will give black, the extract will give black precipitate with sodium sulfide. The extract will give black precipitate with lead acetate. That black precipitate is of lead sulfide. The extract also will give purple color with sodium nitroprusside because of the presence of sulfur. Now, look at this substance. This is called as sulfanilic acid. It is called as sulfanilic acid. Sulfanilic acid will give test for both sulfur and nitrogen. If you take a limited amount of sodium in the fusion, then it is supposed to give blood red color. The extract is supposed to give blood red color with ferric salt. That is because of formation of a complex species. The next element we are going to learn its detection is phosphorus, detection of phosphorus. Here, organic compound is heated with an oxidizing agent like sodium peroxide. All the phosphorus present in the organic compound is oxidized to phosphate and it appears as Na3PO4. Now, to this Na3PO4 we add nitric acid and another substance, ammonium molybdate. This is ammonium molybdate. We are adding nitric acid and ammonium molybdate to the Na3PO4, which is obtained upon oxidation of organic compound with sodium peroxide. You get a substance like this, NH4 taken thrice PO4 dot 12 MoO3. This is called ammonium phosphomolybdate. It has a yellow color. Appearance of yellow coloration indicates presence of phosphorus in the organic compound. Organic compound is heated with an oxidizing agent, sodium peroxide is preferred. Here you get Na3PO4. To this we add nitric acid and ammonium molybdate and we end up with a yellow colored substance which is ammonium phosphomolybdate. This is regarding detection of phosphorus in the organic compound. You also get in this reaction you also get ammonium nitrate and water. Anyhow, not that very important. What is important for us here is formation of ammonium phosphomolybdate, which has a yellow coloration.